Alright guys, welcome back to Chapter 3. In Chapter 3, we are going to get a little expressive, creative. Your creativity will be able to shine in this activity or this unit. We're going to be looking at graphics. So, you've all probably played around with Microsoft Paint. You can do a couple weird things with that, but the idea is, you have a paintbrush, you drag it around, you move it, you draw shapes, things like that. This is going to be a little similar to that. We're going to be doing some very retro-esque graphics for now. And we're going to see what things look like, of course. But, again, if we're learning the basics of programming, we might as well learn to program on a basic, introductory level. There's no point in us focusing on super high-end graphics or anything like that before we learn the absolute essentials of coding. So we're going to use something called the Turtle library. This is pre-built into Python. It works already. It works fantastically. And it's just a cool little thing to play around with. So let's get started with this. All right, I've opened up my Python shell. Again, if you can't open it, if you pinned it to the bottom like I did in the last lesson, awesome. If not, click on Start. We scroll down to Python, whichever version we're using. Open it up. And come on. There we go. Python 3.8 or 3.7 or whatever else you're using. Doesn't really matter. As long as it's 3 point something. We're going to make a new file. So we have this blank window because I don't want to do single line command by command on here. All right. So in order for us to get graphics up and running, first off, we need to actually bring in the graphics capabilities into Python. So what I'm going to do first off is I'm going to put some commented code. Remember, that's with the number sign or the, do you remember it? The octothorpe, to show that this is commented code. So bring in Turtle capabilities. You don't have to write these down. These are just notes so we know exactly what each item does. This is my first line of code. I'm going to say import turtle. What Python does is says, okay, you're looking for something called turtle as a library or as a set of tasks that I can use. Okay, I'm going to take a look and look around, see what I can find. And oh, look, cool, I found the turtle library. Must mean you want to do some graphic stuff. So I'm going to get all those commands ready on hand so that you can use them. And the reason it doesn't just grab all of them is there are millions and millions of libraries, and there are also libraries that are not yet installed on your computer. So it would make sense if you only bring in the capabilities as you need them. Just like when you get a smartphone, you don't install every app, you only install the apps that you need and want to run. So I'm going to import turtle. All right, the next line, we're going to nickname the screen. So I'm going to say screen equals turtle dot capital S, C-R-E-E-N for screen. All I'm doing is instead of me writing turtle.screen, turtle.screen, turtle.screen all over the place, I'm just going to make it so I write the word screen. Okay. Our next line is we're going to make a graphics window. So I'm going to say screen dot setup, and in parentheses, I'm going to put in the width and the height. So let's do something like 800 wide, 500 tall. And these are pixels, all right? And then finally, make a turtle, all right? I'm going to call this guy T1 equals turtle dot capital T, U-R-T-L-E, and close my parentheses on there, all right? So the four commands again, import turtle brings in our capabilities. We're going to nickname the screen so we can use it for stuff easier later. All right, we're going to make a graphics window. We're going to say screen.setup 800, 500, and then we're also going to create our first turtle. Well, we've got enough to make this run, so I'm going to run this. Do not name your code as turtle because, I'm going to stop you right here before we start saving it. If you say import turtle, and then you also have a Python file called turtle, Python's going to say, all right, I'm looking for turtle. Oh, here it is. It's right here. I'm turtle. I'm going to import myself. And then you're going to lose access to all of your commands until you delete the turtle file from your desktop or wherever else you're saving this. So please, please, please make sure you don't call it turtle. All right. What I'm going to do is run module. All right. Open it. Go to my desktop, my programming projects. Nope, that's not it. That's my old stuff. My Python files. There we go. And I'm going to call this exercise 3.1. Now we are going to have 3.2 and 3.3 in this course, so just keep that in mind as well. All right, I'm going to save it, and we should get, it popped up in my other window, but we should have this nice little graphics window. This is our turtle. Hello, turtle. All right, now our turtle can do a lot of different things. We are not going to have it do too many crazy things in this activity because I just want you to understand the basics of building and playing around with a turtle window. All right, so the first command we're going to teach our turtle to do, or tell it to do, is t1.forward, in parentheses, how many steps we want it to move. I'm going to have my turtle move 175 steps. Close my parentheses, and let's give that a run. Run module. All right. My window keeps appearing on the other side, but you're probably seeing your turtle pop up and move forward on there. So my turtle started always in the middle, and it walked forward 175 steps. Now, if I kind of do some estimates, this is 800 wide. So this is about 400 from the center out to here, and 400 from the center out to here. So if I want 175, it looks like it could go another 175, and then have a little bit more. So you can just kind of see that, like, mathematically thinking, all right, well, I don't want to tell my turtle to go 600 steps forward if my width is only 800 wide, because if I'm starting in the middle, that'll bring me off screen. So I'm going to try running this again. All right, and my turtle ran off the screen. Now I can always resize it. Looks like I need to resize a little more. There he is. All right, I can always resize it, but if I'm building a window size to the size that I need, I don't really want to go beyond that. So I'm just going to cut this guy off at 200. All right, so that's the first thing that we can tell our turtle to do. We can put in another step. We can say t1.right 90. Now you're thinking, wait a minute, it already went to the right. That's not what right does. What right does, it actually takes the turtle and has it turn to its right that many degrees. So then why don't we also tell t1.forward, let's have it go another, I don't know, just 50 steps just to see what it looks like. So I'm going to run module, click OK, and my turtle went forward the 200 steps, turned right, and then moved forward another 50 steps. Okay? So we are starting to build some geometric shapes with this. Before we do, I do want to show you some additional things that we can have it do. Instead of going forward, what if I told it to go backward? All right, let's see what we get as a result. Run module again. All right, and it looks like it went forward the 200 steps, turned right, so it's pointing down this way, but then it kind of like moonwalked backwards, or walked backwards and backtracked itself. The equivalent to this, because I would like to show that off, instead of forward 50, I could say forward negative 50. Remember, Python is mathematical. If it can move forward positive numbers, it can move backwards in the form of negative numbers. So I'll try running this. I should get the same result, and yeah, I did. So just something to keep in mind. All right, you can also tell a turtle to move left instead of forward. So what I've done now is it's going to move forward 200, it's going to go left 90, so it's going to actually turn from facing to the right to upwards, and then it's going to move forward. So I think we're going to get a very similar shape again, but that's okay. Yep, I think I clicked check module. I want to click run module. There we go. Okay, and then I kind of did the same thing, but notice now the turtle is pointing in a different direction. All right. One last thing I want to show you is we can also make it so the turtle lifts up the pen so it doesn't leave a mark when it walks. So it's kind of an improvement from the old Etch-a-Sketch. I don't know if you remember what those were, but as you had the device move around, it would leave a trail wherever it went. Well, we have the luxury of actually removing that limitation. So if I say t1.up with parentheses, again, it's not going to make the turtle move up in elevation. What it's going to do is it's going to imagine that the turtle had a marker attached to its shell. So as it walks forward, it drags and leaves a mark on it. But instead, if we attach it to the turtle and we say up, it kind of flips up the marker so it can still move, but it doesn't leave the pen mark anywhere. So let's try running this and see what we get. Run module. Okay. And now what it did is it moved forward the 200 steps, turned left so it's pointing upwards, picked up the pen. Oh, no, sorry. It picked up the pen first, then it turned left. Turning doesn't leave a mark, so we don't really care about that. And then it moved forward 50 spots. Notice how we have like that ghost trail now that we were able to make it so the turtle didn't leave a mark as it moved. All right. Now, what we can do to fix that or to put the pen back down is, you probably guessed it, t1.down with parentheses. Now, if I do this, we're not going to get any new image out of here. Yes, we put the pen down, but the turtle's not moving or leaving marks anywhere. So let me say t1.forward. Let's have it go 73 steps forward. All right. So let's try this now. Run module. Okay. And now it did the forward step, turned left, picked up the pen, or reversed, it doesn't matter, walked forward leaving no mark, stopped here, took a pit stop, put the marker back down, and then moved forward 100 steps again. All right, so I'm hoping you can kind of follow how each of these instructions work and make things change. One last thing that I wanted to point out is if we also say t1.right, and then in parentheses I put, let's say, 63 degrees, and then t1.forward, let's say another 100 steps. We don't have to do these rigid 90-degree angles, but for the assignment that we're going to be working with, you're probably going to be playing around with more rigid or easy-to-use angles. But let's try running this and see what we get. No, I don't want that. Wrong button. Run module. That's what I'm looking for. Okay, so now it still went forward, turned left, or went forward, picked up the pen, turned left, walked forward, put down the pen, walked forward, turned right 63 degrees, and then walked forward another 100 steps. All right, so what I want you to build is, I'm going to do this in Paint because if I show you how to write the code, you're not going to get any better at it. All right, so what I want you to do on one single window, so you have some creativity you need to overcome on here. I would like you to build, first off, a giant rectangle that goes around the majority of the screen, not all of it. I want you to leave a little bit of border space. Then inside of that, and I want it to be proportional. So if your screen is more rectangle-like, I want yours to be more of a rectangle on here, okay? Then what I want you to do is build 2 squares. And these are not going to be perfect squares, but I'm going to make them as good as I can. I want you to build 2 squares of the exact same size. So let me actually cheat a little by copying this in Paint and pasting another copy, because I don't have to be perfect, but I can hold you to that standard because you're learning. All right. Then what I want you to do is I want you to build a triangle in the middle. Doesn't matter how well the triangle's built. And then finally, the last thing that I want you to do, it doesn't have to be in this order, but I want you to build a long rectangle with, and again, this is not going to be perfect, teeth. All right, so I want yours to turn it into a robot face. All right, again, if you kind of understand this, you feel like you don't need to do all of it, sure, but you have to live with that guilt for the rest of your life, and I'm going to know that you didn't do all of it, all right? Your robot needs to look cooler than mine. But that is the first assignment that I want you to do for building a Python graphics program. Get a little creative, have some fun with it. If you want to mix it up a little bit, that's fine. But if you're looking for guidance and enough exercises and trial and error with this, this is the way to go. Because let me explain to you a few things on here. All right. So building this guy, and this guy are going to be easy if you build them first, because then you just have to get over to here. But if you build this triangle first, I don't know why I drew red circles either. That was kind of weird. But if you get to this triangle first, you're going to encounter some problems if your turtle is not immediately facing. Oh, that was bad. That was even worse. All right. If your turtle isn't facing, you know what? We're just going to use arrows. If your turtle isn't facing this direction, this direction, or this direction. All right. Why? Because with these, it's easy. We just know there's 4 different directions, kind of like north, east, south, and west. So we can say, like, you know, if it's up north and I want it to get to like this side or move to this area, I can just have it turn left 90. But if you're building this triangle and you kind of like wing it in terms of like, I don't know, I turned like 73 degrees and then like I went forward and then turned left like, I don't know, 146 degrees that way, you're going to need to be mindful of how to get back to the north, east, south, or west of your directions to get back to drawing everything else. So one of your big challenges for this is you're going to need to be mindful of what is the easiest pathway to take. My suggestion would be to draw the big box first, and then get into an area where you can draw each of these other smaller squares, and then get down and build the mouth and the teeth in it. That way, you just have to get it up to this triangle area and play around from there. It's going to be a lot easier in terms of just getting the turtle to do what you want and getting it to face the right angle. Because again, if your turtle is just slightly angled and you try to make the square, you're going to move at a diagonal and you're going to be like, oh crap, that didn't give me the shape that I want. So now I got to play this guessing game where I try to build the angles back to where I need to go. Another thing that might help you with this is just the properties of a circle kind of represent like how the turtle will be rotating, right? If you get all the way back from where you started, so you get a loop going all the way around, all right, that's 360 degrees. So, you know, if all of a sudden you go, let's say, you know, 74 degrees, and you need to get back to where you were, you could go negative 74 degrees, or you could subtract the 74 from the 360 and then turn that extra amount to get back where you started. All right. I would also recommend using these commented notes, not for each little tiny command, but you may want to build a note for, you know, box for face, and then put in all your code, and then press enter a bunch of times, give yourself some space, and then, you know, square, if I could spell the word square, that would be nice. Square for right eye, and then, you know, square for left eye, and then you could put in mouth. So that way you're kind of like sectioning out areas of your code, so it's going to be a lot easier for you to go back and organize things, or even just figure out where you left off if you take a break. My suggestion for this, take your time, sketch it out on paper a little bit, or on a computer or something like that, and you could even just say like, you know, this is goal 1, this is goal 2, this is goal 3, this is goal 4. You know, once I get there, I've realized that I'm good. And then I know steps 1, 2, 3, and 4. Then I can pick up the pen and then move it and then try to get here for goal 5, then goal 6, then goal 7. And you know exactly where you want to put in each of your little micro goals as you build them. Programmers do not just magically figure out ways to make things happen. It's a lot of trial and error. It's a lot of exploring. And sometimes it's even a matter of like, I'm taking a step back. I'm going to think this through. You know, some really brilliant programmers have been known for just sitting there and thinking for a few minutes, like, how am I going to handle this? All right. Don't go after the instant gratification of, no, I have to do this as fast as possible so I can go on to the next video. I know my videos are awesome and you must love them and you must always want to see them, but no, I'm kidding. But take your time. Have some fun with this. Get good at it. Get comfortable with it. Just because it's not as cool and engaging as the next things that we're going to look at, it doesn't mean that we are going to be building, or that like you have to move forward into building each of these things as rapidly as possible. All right, it's just like a sport. If you want to get good at it, you got to focus on the basics first. All right, we have to learn to crawl before we learn to walk. And then we have to learn to walk before we can learn to run. So the same idea holds for this. All right, take your time. Do not get frustrated. If you do, take a step back, go get a snack, go get something to drink, go hang out. Take 5-10 minutes to go clear your mind. Watch a video of a cat. I got a video on my YouTube channel just called Puppies. Go watch that. That'll make you happy. Clear your mind for a few minutes, and then come back to this, and we'll keep building from there. All right? Thanks for watching. Thanks for joining. I will hopefully see you all in Chapter 3.2, where we're going to unlock a lot of other new features involving graphics. All right. See you soon.